Right, in this next lesson we're going to look at how good is a linear approximation. And sometimes, if you know ahead of time what the tolerance is for your error, we can look at a scenario and try and figure out for what x values would be able to use our linearization to approximate our original function. I want to find the linear approximation for f of x equals sine x, and we want to do that. We want to center that at x equals 0. I would pause the video. You can do this off, on the scratch break and do it right in here. But pause the video and find the linearization for sine x centered at 0, and then start the video up again to check your work. To find my linear approximation for sine x, I find at x equals 0, I got f of 0 is 0, and f prime of 0 would be equal to 1. And so the linearization is 0 plus 1 times x minus 0. So I simplified this and I get L of x equals x. What we're claiming here is that a good approximation, or an approximation of the sine function near 0 is just the function y equals x. And what we want to do, let's first just graph this before we go to part B. Let's graph both the function and the linearization. So we should be in radian mode. We can do y equals sine x for my original function, and y equals x as my linearization. This time I'm going to do a zoom trig to get a nice trig window. And here comes the line y equals x. I mean, already I haven't even zoomed in on this, and this looks really, really good. I mean, in that area between, looks like negative pi over 2 to pi over 2, we look really good. But let's trace on our tangent, point of tangency, and zoom in. And look how straight that already is with just one zoom. This looks like a really good approximation, which it actually is. Let's follow the rest of the exploration here. What we want to find out is we want to use the calculator to find out for what values of x will the approximation be within plus or minus 0.01. And so to do this, first of all, we want to set up our window, and we want to have our negative 1 to 1 be our max, and then for our negative 1 to 1 be our x window, and for y we're going to go from negative 0.5 to 0.05. So I've set up my window to match the window on the worksheet. I now want to find the absolute value of the difference between the sine x and x. So you can do this two ways. You can use the y1 and y2 like we did last time, or we can go in and we'll do math, number, absolute value, and you can literally just type sine x minus x if you want. It depends on how complicated the function is, whether you want to go in and use the vars keys instead. We could just as easily put y1 minus y2 in there. And I'm going to shut off the original equations here. Turn those off. You don't even have to type them in. You can literally just type them in for the sine x minus x. And so this is going to be my error, sine x minus x, the absolute value. I want to find out for what values is that good between plus or minus 1. I'm going to type in y equals 0.01 in my y4 here. And because I'm using the absolute value, that's why I don't need to graph negative 0.01. And so let's go ahead and graph the error along with the horizontal line y equals 0.01. So here's our error, and here's the graph of y equals 0.01. So now we just want to find out for what values of x will our error be between plus negative zero point zero 0.01 and zero point zero 0.01? What I want to do is just, let's hit trace. I want to find the intersection point between where the error function and the line y equals 0.01. I want to find out where they intersect. So I'm going to hit second calculate, and we'll do intersection 5. Now it'll ask you for the first curve. You just hit enter. You're on the second curve. Hit enter. You do not have to make a guess. Just hit enter again, and the calculator will tell you the x value. I've got negative 0.39249. So we'll round that to 4 decimal places. I know I want to be within negative 0.3925 for my smallest value of x, and we'll go over to, we're going to trace, and we want to get closer to the other intersection point. You can use the arrow keys to do that. So using the arrow keys, I got close to the intersection point, and I'll hit second calculate again, hit 5 for intersection, hit enter for the first curve, enter for the second, and enter again for the guess. And I get 0.3925 for the positive value. If I want my error to be within plus or minus 0.01, I would be able to use the linearization for values of x that are between negative 0.3925 and positive 0.3925.